Good afternoon, everyone. My name is Ndene Poni, and I'll be starting you off on our Brownfields development. These are my teammates, Tombi Futi Luma, Sandile Ker, and Bushle Matikiti, which will be introduced to them when they're starting their section of the presentation. And this is our table of contents. You can see all the sections are there and the headings of the sections. Okay, what is brownfield development? Brownfield development involves taking existing code and modifying it, changing its functionality, and adding new features into it. If I could make an example, I could say bug fixing, implementing user interface changes, and actually removing or adding new features, new functions. Yes, that would be it. But I would say it's more complex than the greenfields development because it requires you to learn about the existing code and learn how the code works and the functionality of the code and everything about the code. Whereas in greenfields development, you would start off from scratch and everything is implemented by you and it's organized by you. You know every place, every function where it is. But this one you have to learn about the existing code and break the existing code bit by bit, but also adding new features. Now we can move on to the next slide. Section A, which is software development source files. We utilize Git for managing our source files. Our repository has a clear structure with branches for different features, and that ensures organized file. We maintain naming conversion and directory structure to ensure the correct source files are easily identified, and that minimizes the confusions and errors. And we carefully manage dependencies by referring the specific versions of the library, and that just helps the capability and sustainability of the project. And we follow the curriculum by retrieving and updating source files and ensuring consistency and compliance with the project requirements at all times. Our version control practice includes commenting with very descriptive messages and pushing regularly so that nothing is lost. Doesn't matter what you did, just push it, and we'll look at it when we're having our stand up. Then after the stand up, we would have a merging meeting where we would merge and everyone is there so that no one merges. Then there's a merge conflict that we can't resolve. At least everyone is there and we would resolve that conflict at that moment. And that's how we manage our software development source files with Git. And these are the pictures of our GitLab. As you can see, there we are clearly uh, having names for our branches and different features. Yeah, so every feature has a different branch. We'll create a different branch for any new features that helped with the merge conflicts. There you can see our commits. Uh, and as you can see, it's not just one person committing, different people. Yeah, and that would be section A. Thank you.
Hi, my name is Anjile Victoria Care, and I'll be doing section B. Section B is about code and design conformance. This section appears to focus on using ease of development SQL, a lightweight object relational bridge for Java. And to implement the ORM, here's a breakdown of what section covers. Ease of development SQL. Here's an overview for the ease of development SQL. Ease of development SQL is a lightweight ORM tool for Java that simplifies object relational mapping using JDBC. It uses annotations to specify data mappings and to generate implementation code for data access interfaces. Here are the key components of ease of development SQL. The first one is ease of development consists of data object, data access interfaces, and the query tool. Data objects are simply Java classes representing entities in the database. The DAIs declare methods, annotate with SQL queries for reading, updating, creating, or deleting data. The query tool generates implementation code for DAIs and provides methods for database interaction. Data objects The data objects are passive containers for data, conforming to Java Bean conventions. They can have public fields or private fields with annotated setter methods. Data objects represent entities in the database and are used to transfer data between the application and the database. We are defining data access interfaces. The first one, um, the data access interface declare methods annotated with SQL queries for database operations. The second one, methods can be defined for reading, writing, updating, or deleting data. The last one, annotations specify the SQL queries to be executed for each method. And creating query objects. Query objects are instantiated from the data access interface using the query tool. They encapsulate the database interaction logic defined in the data access interface. Query objects are used to call the data access methods defined in the data access interfaces. And overall, the integration and usage, the use of ease of development SQL, a JDBC connection object is required along with the data access interface class. The query tool getQuery method generates a query object for interacting with the database. Data access operations are performed using the method defined in the query object, which internally execute SQL queries. Overall, the ease of development SQL simplifies ORM by providing a straightforward approach to mapping Java objects and to relative database tables, making database interaction in Java applications more efficient and manageable.
My name is Domfuti Godness Luma, and in this section I'll be discussing about database management systems, also known as DBMS. In the world of software development, DBMS plays an important role in ensuring the efficient handling of data. These systems offer a range of functions, such as organizing and retrieving data to manage it effectively. From small applications to large ones, understanding DBMS is crucial for building robust and effective applications. Before we dive into the details of DBMS, let's first find the problems it aims to solve. Imagine you had a system that lost all of its data each and every time it shuts down. Even worse, imagine inconsistencies in data due to multiple users accessing and modifying it simultaneously. These are typical problems that comes with conventional data storing techniques. However, DBMS offers solutions to database management systems comes in a variety of forms, each catering to different data needs. Among the well-known varieties, we have relational databases, NoSQL database, graph databases, and key value stores. Examples of the usage of database management systems is in banks. Banks are able to store a customer's personal details and are able to access and modify it. Also, another example is in libraries. Librarians are able to store information about books and can be able to lead you to where the book that you want is in, like the type of aisle it's in or the type of book that you want. In our Robot Worlds project, we used SQLite as a database management systems. We stored data using tables by creating a relationship between two data or multiple data entities. We used SQLite. While it has its own disadvantages, such as that it doesn't allow multiple user control. It has its own advantages, of which some are that it's cheaper for smaller projects, and also it doesn't require a server to run. We utilized a driver manager to connect to the database. SQL, the structured query language, was used to interact with the database by the use of CRUD. We're able to create, read, update, and delete data. At the end of our project, users were able to query, update, and manipulate data. Other examples of relational database management systems are PostgreSQL, MySQL, and Oracle database. Our DBMS offers features such as data integrity by ensuring the usage of constraints like foreign keys and primary keys to create a relationship between two datasets. Our DBMS also allow multiple user control, and our DMS ensures that the data is scalable, meaning that it caters to changing amounts of data, making it suitable for both small-scale applications and enterprise-level systems. Relational database management systems offer features like end-user tools, and those are the graphical user interface GUI to be able to visualize the data. And it also offers features like command line interfaces to be able to connect to your database in your own machine, like in your team. Relational database management systems offer end-user tools such as the graphical user interface to be able to visualize the data. Also offers command line interfaces to be able to connect to your database in your local machine by using the terminal. The end-user tools have their own limitations, of which is that data can be lost and that the security can be compromised.
Hi, my name is Wushe, and I'll be covering section D, which is evaluating SQL implementation and data management in web applications. In this section of the project, it aims to implement saving, deleting, and restoring the map of a robot world in a rational database. This involves structuring the data into tables and defining the primary keys and foreign keys, also understanding the conceptual foundations of rational theory. We dive deep into SQLite, the language that we use to interact with our rational database in Java. It also connects the table to the website, which enables us to integrate the SQL functionalities into our Java application, and we're also able to see the data. Our ultimate goal is to enable the robot world user to save their world into a database, to also delete it using the delete command, and to save it using the save command, and also for them to be able to restore the world. The user is also able to see this in the database. And we have created the table under the DLA folder. And to create the table, the SQL code we've put it in a class called create table. So this allows the user to create the table that for their world. Yes. So this is the SQL code. In this code, this is where we create the table, and this is located under the database folder. It has its own class for creating the table. Also have a class for deleting the table. Yes. So in this class where we create the table, what is shown on the table is the ID, the name of the world, and also the height and the width of the world. Yes. And so this is where the world is also saved. So if the user saves the world as I don't know, banana, the world will be saved as banana. So that will be the name of the world. And the user will choose the width and also the height of the world that they want it to be. So this is then where it saves it and stores it in the database. Can you go down a bit to just show the code for that? Yeah. So this is where the world is saved and created. Okay, yes, it's understandable. So the SQL code is understandable. It's also very easy to read and easy to. The SQL code that creates the database is located in the folder called database, and there are different classes for it. So the first class that creates a database and the other class deletes the database. So in this code, this is where this is where the table is created, and then it links to SQL. So whatever data it gets from Java, it links it to SQL. If we go further down, we can also see that the user is able to insert the world within the table, that goes within the table. And what we see in the table is we see the key, the name of the world that the user created, the width, and also the height of the robot world. Can go a bit down. Yes. Full stop. And then if you go to the next class, this is where the table is then deleted. So this creates and saves the world. And then the next class, which is called delete tables, the user is then able to delete the world that they have created. Thank you.
And database access verification and computer programming testing. The requirements were to use expert tests, and which is what we used. These are the questions which I'll be going through while doing this section. The first question is showcase the execution of operational steps identified in the test plan. Within our acceptance test for the robot world project, we demonstrate the execution of operational steps outlined in our test plan. Each scenario, such as valid launch command, should succeed and invalid launch command should fail. This reflects the specific operational steps that we executed and validated. In our test, we have the test valid launch command should succeed. We first checked that the client is connected, and if their launch request is a valid launch request, they should receive this response. Which says okay. But if the client inputted an invalid launch command request, maybe they misspelled launch, or mainly if they misspelled launch, they should get this response. Now for the second question, which is show the use of input data as specified in the test plan during the test. Our acceptance test vividly showcased the utilization of input data. For instance, we sent both valid and invalid launch requests to the server with a precise command and argument, ensuring that our tests are accurately reflecting the real-world usage scenarios. If we would go to the code, you can see if a person sends a valid launch request, they should receive a string that will be sent to the client side with. Now, Now for the third question, which is outline deviations from the test plan with explanation during the testing. While executing our tests, we transparently outline any deviations from the test plan and provide comprehensive explanation for each. For example, when encountering a scenario where your expected outcome differs, such as receiving an error response to the invalid launch command, we send a message which will say unsupported command, which is also telling the client that the command is unsupported. The following question, which is follow the standards and procedures specified in the test plan for testing and retesting. We ensure consistency and reliability in our test execution. Here's how we integrated these standards into the provided example. Firstly, we used at before each to connect to the server before each test. Before executing each test, we establish a connection to the server or to the robot world server. This ensures that our tests are conducted in the context of running a server consistent with the real world scenario. And we used after each to maintain a clean testing environment. We stopped the game server gracefully after completing each test. This prevents interference between successful tests and ensures accurate results for the test. For the next question, which is show the testing of your code's logic path. Demonstrating the testing of code logic paths involves systematically validating different execution paths within our code base to ensure that each function or class behaves as expected. If I would do an example, I would use misfire test. And if we would go to that, yes, misfire test. So with the misfire testing, in the misfire testing method, we simulate the logic path where a missile is fired but missed its target. This path involves sending a fire command request to the server and verifying that the response indicates a miss message. The test validates the behavior of the server when a missile fails to hit its target. And okay, for the SQL database questions, I can answer those because we didn't do any tests for the database. Questions after that I could answer is show records for all tests executed during the testing of a computer program. If we go back to the code and we run maven test, and okay, as you can see, the build was successful, and if we go up, you can see Ran 23 tests, zero failures, zero errors, zero skips, and everything worked well. If we move on to the next question, which is identify variations from expected test results from testing your code and give reasons where available. If we could go in here, let's do launch again. Example for that would be the invalid launch command. When someone inputs an invalid launch, there's a result, there's a different response for that. As I stated, now if we go to the next one, which is show that recorded results can be reproduced if the tests are repeated under the same conditions while testing a computer program. Okay, if I run Maven again, okay, now if we go to the test again and do Maven test, we run it. And if we look at the results, and 23 test pass or failures were errors are script. Now if we move on to the next question, which is could go again. And these are all our tests. If we go into look, you can see everything is still passing, everything is still good. And if we go into this one, everything, let's see another one, everything is still good. And if we go to the last question, which the things that can be improved would be to create testing for the database, since we didn't even touch that one. And yeah, I think if we could improve something, it will be there. Thank you.
Section F, I'll be discussing the documentation consistency and design adherence in our Brownfield module project. Documentation plays a crucial role in software development and provide clarity and guidance for both developers and users. Documentation creation process. Our documentation creation process began by identifying the key components needed to effectively communicate the project's functionality and requirements. We followed established guidelines and standards to ensure consistency and clarity throughout. And showcase the documentation components. Let's take a look at some examples of the documentation components we created. Here, you can see our README file, which provides an overview of the project's installation instructions and usage guidelines. Additionally, we developed the design documents outlining the project's architecture and a user manual for end users. And for consistency with program functionality, our documentation reflects the program's functionality accurately. We made sure to document each feature and functionality in detail, ensuring consistency between the programmers, ensuring consistency between the program's behavior and the information provided by the user. The plan and the design adherence. Throughout the documentation creation process, we adhered to the plan and design established during the initial project planning phase. Our documentation reflects on the design decision made, ensuring alignment with the project's goal and objective. And the review and the structure. The structure of our project, of our documentation is logical and organized, making it easy for readers to navigate um, and understand. Cleared, we have clearly defined how the program's specifications have been have been met and provided comprehensive information to support our claims. In conclusion, our documentation demonstrates a high level of consistency and adherence to high to design standards, and by maintaining clear and um, by maintaining clear documentation, we ensure that our project is well documented and accessible to both developers and end users.